All right, Algebra 2, this is the SOL Coach Book Problems, which is your homework assignment before the SOL exam. So problem 1 says, which is the parent absolute value function? So remember that absolute value is y is equal to the absolute value of x. So if you made a table of values, it would look like this. You have x and y, and x can be anything. But because you take the absolute value of that number, all of the y's are positive. So you'll have 2, 1, 0, 1, 2. So if you look closely at the values, you will see that that's going to match graph B. In problem 2, it says, how could the real number -7 be written as a complex number in the a plus bi form? Well, a is the real part, and b is the coefficient of the imaginary part. So if you have no imaginary parts, then the b would be 0. So your number would be -7 for the a and 0 for the b. So that would match answer F. Problem 3, a can't equal -3. If you look at the problem, that's because it would make the denominator 0, which is the simplest form of the following expression. So you're going to have to do a little bit of factoring here. In the numerator for the second rational, you can factor that as a plus 3 times a plus 3. And the denominator has a common factor of 2a, and that's times a plus 3. And then you can do a little bit of canceling, so that this a plus 3 can cancel with this one, and this a plus 3 can cancel with this one, and so now what you have is, it looks like 6a squared over 2a. So 6 over 2 is 3, and a squared over a is a, so it looks like that would be answer B. In problem 4, it says, what are the solutions for the following equation? There are so many methods you could use here. You could always do quadratic formula to solve a quadratic equation. You can factor it, and also you can graph it on your calculator. For this one, it seems like factoring is the quickest, but remember, you can always graph this on the calculator and just look at the x-intercepts. In this case, the numbers that multiply to -54 and add to -3 are -9 and 6. So you would have x minus 9 times x plus 6 equals 0. And then if you set each factor equal to 0, you get your solutions. So x equals 9, and then the other one would be x equals -6. So that looks like it matches answer G. Okay, on to the next page. So you have a graph of the square root of x plus 2, and it asks for the range. So remember that the range is going to be the y values. So we're looking at the y values. The y values start down here at 0, and they keep going up, 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 up. And because there's an arrow here, it means that they're going to go to infinity. So that's going to be everything from 0 to infinity. And actually, you want a square bracket there to include the 0. But we have a different notation in our answer choices. So the one that matches this would be A. A says y is greater than or equal to 0. Problem 6 asks for the simplified form of the following expression, and we've seen two ways to write these answers. So it's important to look at the answer choices before you start working on this. In this case, we're going to just simplify the radical. So you want to take the numbers that are underneath the radical, and you want to make them into numbers that are divisible by 3. And I'm having a hard time seeing these numbers, but I'm thinking it says -27x to the 4th, y to the 3rd. So the cube root of -27 is easy, that's -3. And the cube root of y to the 3rd is just y, it's 3 over 3. But for the x term, we're going to have to split that into 2 terms. So I have x to the 3rd times x to the 1 is the same as x to the 4th. And I do that because I can do 3 divided by 3 and take out an x to the 1. So that gives me -3 times y times x times the cube root of x to the 1. And that's going to match one of our answers here. It looks like answer G. All right, problem 7 asks about the end behavior of negative 4x squared plus 1. Well, that would be a good problem to look at your graphing calculator for. So press your on button. Let's try that again. And your y equals, and put in the negative 4x squared plus 1. And you graph it, and then you can see your end behavior here. They're describing it very generally, but let's see, on the left it's down and on the right it's down, so that matches answer D. So let's see, let's go back over here and choose answer D. Number 8. Alright, for this one you're going to want your formula sheet, although they do give you the formula right here. And it says, what is the 10th term of the arithmetic sequence for which the first term is 16 and the common difference is negative 3? So let's fill in these numbers here. We want a sub 10 because we want the 10th term. And they tell us the first term is 16. And because we want the 10th term, that means n is 10. So 10 minus 1 would be 9. Oops, and I forgot my plus here. And that's times d. So I have a sub 10 equals 16 plus 9 times d. Now remember, the d is also negative 3, so I have 16 plus 9 times negative 3, and you put that in your calculator. You have negative 27 and 16, so that looks like it would be negative 11, which is answer H. In number 9, they show you the graph of a function, and they say, what does this graph show about the equation? So the equation has two distinct real solutions. No, it looks like it has just one solution right here. This equation has only one distinct real solution. Seems like B should be the answer, but you want to check all your answers. It has no distinct real solutions. Remember, that would be if you never touch the x-axis. And the equation has roots with imaginary components, so C and D would actually be the same answer. So the right answer is answer B. It has one solution right here where it bounces off the x-axis, and that's a double root, but that doesn't matter here. It's the one distinct real solution. So we're going to go with that one. Let's do one more page in this video. Okay, problem 10. What is the solution set for the following equation? It's an absolute value equation, which means it's going to have two answers. You're going to set the equation equal to 6 and negative 6. So if I just set 1/3 x plus 3 equal to 6, I can subtract the 3 and get 1/3 x equals 3, and multiply by 3 and I get x equals 9. So 9 is one of my solutions. Then you want to set it equal to the opposite of 6. You want to set it equal to negative 6. When you subtract 3, you get 1/3 x equals negative 9, and you multiply by 3 and you get x equals negative 27. So your solutions are 9 and negative 27, and that looks like answer H. Alright, problem 11. It's actually pretty hard to read this here. So I'm going to come back to problem 11. I might have to actually make this bigger. Let's see if I can do that. Okay, there it is. So it looks like we have the 4th root of x to the 8th minus x, the square root of x to the 4th. So that would give me x to the 8 over 4 minus x to the 4 over 2. So that's x squared minus x squared, which would just be 0. Okay, problem 12. We have a system graphed and we want to know the solution set. So the solution set is where your system crosses. So that would be here and here. So it looks like negative 1, 0 is a solution, and then the other one would be 1, negative 4. Looks like answer H. Alright, in problem 13, each locker code has 4 digits and no digit can be used more than once. So for the first digit, you can choose between 0 and 9, so that would be 10 choices. But then you've already used a number up, so for the next one you only have 9 choices. And then the next one you only have 8 choices, and the next one you only have 7 choices. So you're going to want to multiply those numbers up and get your answer. So let's see. we're going to do 10 times 9 is 90, and 8 times 7 is 56. So 10 times 9 times 8 times 7 is going to give us 5,040 solutions. So that means our answer here is C. And in problem 14, no denominator is equal to 0, which is equivalent to the following expression. So we need to get a common denominator to solve this. So your first fraction is going to be multiplied by z plus 4, because you need z plus 4 in the denominator there, and z plus 4. And the second fraction is going to be times z over z. So if I have z plus 4 times z plus 4 in the first numerator, I get z squared plus 8z plus 16. And in the second fraction, I just have z times z, so that would be minus z squared. Alright, and my denominator is z times z plus 4. So these cancel out, and I have 8z plus 16 over z times z plus 4. And 8z plus 16 is the same as 8 times z plus 2, if you just factor out that 8. Alright, so that's a few pages in. We're going to stop this video and go to the next one.